Alright, this title is just huge. Identifying solutions to linear equations in two variables. That just sounds so intimidating. It's just terrible. It's really not that bad. All it means is that they're going to give you an equation, which means something with an equal sign. Two variables means that they're going to have an x and a y. And then identifying solutions means that they're going to say, hey, dude, does this ordered pair work? When you plug this for x and this in for y, do you get a true solution? And that's all we're going to be doing is we're going to be taking what they give us for an ordered pair, stuffing it into an equation, and PEMDASing it and seeing if we get, see if it works out or not. That's it. Sounds really scary, but if you can PEMDAS, you can totally do this. What else did I want to say? That's pretty much it. I think, yeah, let's just get started. So I think if you're using the ALEKS software, they like to give you two equations at one time just to see. So we'll do that same thing here. The first equation we'll do y equals negative 5x minus 12. Notice, yes indeed, there's an equation. It's a linear equation because there's no exponents. We have an x and a y. Bingo, two variables. And here is another one, negative 5x plus 2y equals 6. So anything that's called a solution for either of these will give you a true statement. The left side will equal the right side. Let's check this guy first. Let's say they want us to check negative 4, negative 7. So all we're going to do is we're going to write down each of the equations above. Wherever we see an x, we're going to put in negative 4, because that's our x value of our ordered pair, and we're going to put in negative 7 for y, because that's our y value. Ordered pairs are always x comma y. Alright, so let's try it out for this guy first. Our y, we're going to copy it over, is negative 7 equals negative 5 times our x value they gave us is negative 4 minus 12. So we need to PEMDAS the right hand side and see if we get a true equality. The negative 7 doesn't change. Multiplication comes first, so what's negative 5 times negative 4? That's going to be positive 20. Copy over the rest. Again, I like to take it in small steps so I don't goof it up. And then what is 20 take away 12? Well, that's 8. That's not close at all, so that does not work. It's not a solution for that. Now let's take it for this same equation over here. We have negative 5 times our x value, which is negative 4, plus 2 times our y value, which is negative 7, equals 6. So now we have to PEMDAS the left-hand side of the equation. Multiplication comes first because we have no exponents. 5 times negative 5 times negative 4 gives us positive 20, plus 2 times negative 7 is negative 14. And then what is 20 plus negative 14? That is 6. 6 equals 6. So this one is a solution for negative 5x plus 2y equals 6. Alright, let's test another ordered pair that they give us. Negative 3, negative 3. And again, we're going to use the same two equations up at the top. These two here. We'll take the first one. This time we're plugging in negative 3 for x and positive 3 for y. So I'm copying that top equation. Wherever I see an x, I'm putting in negative 3. Wherever I'm seeing a y, I'm going to put in a 3, positive. Alright, so y is the first thing, so that's 3 equals negative 5 times x is negative 3 minus 12. Alright, I got to PEMDAS the right-hand side of the equation. Negative 5 times negative 3 is positive 15. Take away 12. And what is 15 minus 12? Woohoo! That one works. Now let's check negative 3, positive 3 for the second bottom equation. Negative 5, we need an x value. They told us to put in negative 3, plus 2 times our y value is positive 3, equals 6. Let's see how this works out. Negative 5 times negative 3, 2 times 3. Whoa, no way, huh? 21 does not equal 6, so this is false. Again, this is all you're doing. So the title is Identifying Solutions to Linear Equations in Two Variables. Oh, I'm shaking on my boots. I'll never ever be able to do that. Guess what? If you can PEMDAS what you learned a long time ago, and you know that an ordered pair is an x and a y in that order, bam, you can totally get this done. Alright, I'm going to do one more example. Again, if you want to pause it at any point and work it out for yourself to see if they work, totally do it. You should hopefully feel pretty confident in this. If not, come find me because maybe I'm just not explaining something right. But to me, it's just one of those things that the topic sounds terrifying, and then when you actually put pen to paper and understand what you're doing, it's like, really? I can do that. All right, so we have two equations here, and I'll just put a box around them. And we'll just verify that to see if the ordered pair 5, 2 works for each of these. So we'll start off by the top equation. Wherever we see an x, we're putting in 5. Wherever we see a y, we're putting in a 2. And I highly recommend, I know this sounds goofy, but I'm not kidding you. This will help you. Anytime anybody gives you an ordered pair, walk over there and label the x and the y right away. It just helps you out, because if you're ever faced with a problem that has ordered pairs and you don't even know what you're supposed to do, sometimes just labeling it x and y all of a sudden makes you go, oh, wait, I just labeled that x and there's an x in the equation. What happens if I plug it in? So, like, totally just label. Anytime you see an ordered pair, stuff it in there. All right, copying over the top equation, we start with an x, which they told us to use 5, plus 3 times our y value is 2, equals negative 11. All right, let's PEMDAS this. Remember, we multiply first. This is not happening here. No way. Nope, not happening. False. All right, let's try the bottom equation. We have 8 times, what's our x value? 5, plus 9 times 2. That's not even close. All right, I can already tell. 40 plus 18 does not equal 2. Bad. All right, let's try another set of ordered pairs. Or let's try one last ordered pair. We don't want to beat a dead horse. Is that what they call it? Let's try 7, negative 6. Again, as soon as you see an ordered pair, I don't care if you're like in calculus, label it. Okay, 7 is our x, negative 6 is our y. We're taking our top equation. X, which is 7, plus 3 times y, which is negative 6. Does that equal negative 11? Well, let's check it out. What's 3 times negative 6? Negative 18. 7 plus negative, oh, I like that one. That one came out good. Yep. Alright, let's check 7, negative 6 for our bottom equation. 8 times our x, which is 7, plus 9 times negative 6, which is our y. Does that equal positive 2? 8 times 7, 56. 9 times negative 6. Hey, this is a friendly ordered pair. 2 equals 2. Bingo. Alright, if you have any questions, come find me. If I didn't explain something all the way, just say I didn't get this little step here and I'll set you straight. Alright, thanks for listening.